Alright guys, this is 7.2. I'm Mr. Sal. We're going to be looking at more order of operations. Thanks for watching. And this is during the pandemic, so hopefully everyone's doing good, staying safe out there. And let's get started on this. Alright, so to get us started, I'm going to be using that order that we kind of wrote out from last time. It's the same one, we just copied it. Just to help us remember the order of the operations, okay? So first off, we're going to be starting with parentheses, and I do see a set of parentheses on this problem, so I got to do whatever's on the inside, which in this case is 2 plus 6. That's going to be 8. Now again, I rewrite the rest of the problem, and I just want to show the operation between the 3 and the 8. Okay, again, that's a multiplication part. So we've checked off the parentheses. I don't see any exponents, so we can check that off. And now we go straight to either multiplication or division. Now again, I've shown the multiplication here, so we do have the multiplication between the 3 and 8. 3 times 8 is 24. So now the problem is 5 plus 24. I don't see any division or other multiplication, so that checks this one off. And now I do 5 plus 24, that's my addition or subtraction, which is 29. So there was no subtraction, but there was addition, and I can check that off as well. So again, the purpose of this is to see that we're just going through each of these, checking them off as we go. And if by chance on this assignment or classwork, if we see any parentheses inside parentheses, we talked about that last time, but if we see any, then we can go over it. So same thing on this one. I don't see any parentheses on this one, so we're going to check that off. I do see exponents right here, the 2. Now that would be 3 times 3, which is 9. Now again, not everyone does this, but I like to show the rest of the problem as we work through it. So I got 48 minus 2 times 9 plus 16. Now I don't see any other exponents in this problem, so it checks off that one. Then I'm going through the rest of this list. I'm on 3, either multiplication or division from left to right. I do have this multiplication right here with a 2 and 9. 2 times 9 is 18. So now my new problem is 48 minus 18 plus 16. And I can check off multiplication or division because there is no more of it in this problem. So on this next problem, I have subtraction and addition, but the subtraction comes first on the left, which is 48 minus 18. That would give us 30, and now I've got the plus 16. Now that checks off the subtraction, but I've got to go to the addition as well. And that would be 30 plus 16, which is 46. So the answer to this one is 46. Now on this problem, it doesn't show the parentheses, but we definitely could show them. And we see that we've got the square root in the list, right? So it's right, like taking the square root of 64. And the square root of 64, that's a perfect square of 8 on that. So again, this brings us back to the full expression now. 11 to the power of 2 minus 8 divided by 4 times 7. Now just from that, hopefully we can see that just by doing this out of order, we could get a very different answer than what we should. So that checks out the parentheses because I don't see any others. And next I go to my exponents, and I do have exponents right here with 2. Now again, expanded, this would be 11 times 11, which is 121. So now the new equation or expression, 121 minus 8 divided by 4 times 7. And again, this checks off the exponents because I don't see any more. And I'll move into either multiplication or division. Now again, some people would be like, I see the multiplication right there, and it's please excuse my dear Aunt Sally. So that is what I'm going to do. Please do not, we do not want to do that first. we have to do the division first because it is the first one on the left. 8 divided by 4 is 2. Now just from that, I got 121 minus 2 times 7, and I still have some multiplication in this problem, so I've got to do that. 2 times 7 is 14. Now right here, I don't see any more multiplication or division, so I'm going to check that off. But I do have the subtraction left, 121 minus 14. Now we could show that in work right there, 121 minus 14, and you'd have to borrow to make that 11. So should be 107 on that, which is our final answer, 107. And that checks off that last one for us. Again, more order of operations. Now this one is pretty big, and we may look at this one and I feel a little discouraged, right? Because there's a lot of parentheses, there's a lot of numbers even. Just don't get discouraged. Remember, that's the nice thing about the order of operations. It's going to break these problems up into smaller, more manageable problems. Now, the way that I do this is I'm going to focus first on the numerator. And the reason that is because the fraction lines fall under this category of parentheses. So I do need to focus on these first. Okay, so what that means is I'm strictly focusing on the numerator part of this. Right now I'm not even worried about the denominator, okay? So in the numerator, I start with the order of operations once again. So I'm ignoring the rest of this, the denominator from the original fraction, and I start over with parentheses, right? So right here I have this set of parentheses, which is 8 minus 6. And 8 minus 6 is 2. So the rest of that numerator would be 4. And that 2, it's in parentheses, right? To the power of 3. And then we got that plus 3 right there. Well, now that we got those parentheses out of the way, I would be focusing now on the exponent right there, the 2 to the power of 3. Which is the same as 2 times 2 times 2, which is 8. So now I got 4, and that would be multiplication between the 4 and the 8. And then I've got that plus 3. So now I would be looking at, because there are no more exponents, multiplication or division. And I've got the multiplication there. 4 times 8 is 32. But then I've got to add the 3. And the addition there, because there's no more multiplication or division, 32 plus 3, makes that 35 as the numerator. Alright, so I've taken the numerator, the original numerator back here, and I simplified it to just the 35. But now I need to do the denominator as well. So the work is complete for the numerator. Just focusing on the denominator, we have 2 sets of parentheses, right? We got this one right here, and then we got this one right there. And then we got this one here and this one. Okay, so I'm going to start with just one at a time, moving just like I would with steps 3 and 4 from left to right. Now the first one, 3 plus 14, that's going to give me 17. And then the 6 plus 6 is 12. Now the operation here shows it as subtraction. Well, that was the parentheses. I don't see any exponents in the denominator. And I don't see any multiplication or division in the denominator. So I'm going directly to addition or subtraction, which in this case is subtraction. So 17 minus 12 is 5. So since this is simplified now, I can show these as fractions with my work, but the final simplified form is going to have a 5 denominator. Now remember that this fraction, particularly the fraction line, is a division sign, okay? So really what I have right now is 35 divided by 5. And you could do the long division on this. In any case, 5 goes into 35 7 times. which is the final answer on this problem, 7. Now that may have seemed like a lot of work. The nice thing is, whoever wrote this problem made the denominator come out like it was fully simplified after, well, just 2 steps really. And that happened because we did the order of operations. You could have shown this with the second step, right? You could have shown the 17 minus 6 plus 6, and then the 17 minus 12. It doesn't really matter, because parentheses also work pretty much like these ones do from left to right, unless they're on the inside of another set of parentheses. Alright, this is on the next page, so we see some brackets now. But again, the order will remain the same. Now, if you wanted to use distribution, you could use that with step 1, because it gets rid of parentheses. I'm not going to do that, though, because I like just straight order of operations, especially where there are no variables. So I see this set of parentheses first, right? 20 minus 11 is 9. But then I have this set of brackets, which on the inside of it has this set of parentheses. So I do need to do those first, meaning the 1 plus 4, because, again, I would be looking at that set of brackets as a separate kind of quantity or a separate problem that I would be looking to simplify. And that would mean that we need to start the order of operations over from the beginning inside that set of brackets. So 1 plus 4 is the parenthesis part of that, which is 5. So on the inside of that, I've got 10 divided by 5 now. So inside of the set of brackets, there are no exponents, but there's this division part, which shows as 10 divided by 5, which is 2. Now I'm going to keep these in the brackets, just to keep this consistent, but brackets in this case is representing parentheses. So I've got, right now, I've got 3 multiplied by 9 plus 4 to the power of 2 minus that last 2 in parentheses. So I've evaluated and simplified all the parentheses as far as I can go. So that's checked off. And I'm going to look now to the exponents, which is the 2 right there. And that would be 4 times 4, which is 16. So this is what I have right now. And I'm just going to point this out. You could do it later. But since it's minus this, what is a positive 2 right here, is I'm actually going to get rid of that brackets and show it as just minus 2. Alright, so I showed the brackets in that previous step just to show that the 2 came from the brackets. But I don't really need those anymore, and they may cause more confusion if we leave them there. So as of right now, the exponents are complete. So I'm going to check those off and move to multiplication or division. Now that's 3 times 9 right there, which is 27. So there's my multiplication part of this. There was no division, so I just write down the rest of the problem, which is 27 plus 16 minus 2. Now in this specific case, I'm finished with multiplication or division. And I have addition first, going from left to right, which is the operations I'm on. So 27 plus 16 should be 43. And now the new problem, 43 minus 2. So I'm left with just the subtraction part of that. 43 minus 2 is 41, and that completes this 4th step in the order of operations. And that right there would be our final answer for this problem. It was a simple 41. Alright, so on these problems, again, we got some parentheses that we need to focus on first. In fact, it's 2 sets of parentheses. So again, the nice thing about the order of operations, I get to ignore this exponents and the divide right there. I'm just focusing on the parentheses. So from this set of parentheses, I got 3 minus 9, which would be, I'm kind of like adding the negative 9 right there. So I've got more negatives than positives, and 9 minus 3 is 6. So that's a negative 6. And then the set of parentheses to the right there, 4 minus 2 is 2. So rewriting this problem, I've got negative 6 in parentheses to the power of 2, which is important. And we're dividing this by 2 to the power of 2. And that concludes the parentheses part of the order of operations. But now I need to go to the exponent part, which are the powers of 2 for negative 6 and 2. So this one would show as negative 6 times negative 6. Now this is an even number of negatives being multiplied, which makes the answer a positive 36. And then over here we got 2 times 2. That's not too bad. That's just 4. And looking at this problem now, there is no more exponents, so I can check that off. But then I've got the division part of this right here. And 36 divided by 4 is 9. Now there's no other operations. It completes the division, which means it also completes the addition and subtraction because there's no more operations. But this would be our final answer right here, 9. Alright, on this problem we do have a set of parentheses in the form of absolute values. So we'd be doing this subtraction first, 3 minus 6, or 3 plus negative 6, whichever you prefer. In any case, we have more negatives than positives, and 6 minus 3 is 3. Now this is the absolute value of 3, which is asking how far away negative 3 is from 0, which is 3. So the new problem now shows as 3 plus 4, and there was multiplication between the 4 and the absolute value, so it's 4 times 3 there. And that completes the absolute value or parentheses part of this problem. I don't see any exponents, so I'll check that off. In fact, I don't see division, but I do see multiplication here. 4 times 3, which is 12. So now the problem simplified to 3 plus 12, and there is no more multiplication or division, so that checks off. Now I've got my addition part. 3 plus 12 is 15. And again, since I have a single number out of that, obviously there's no operations, which means my final answer for this one is 15. So order of operations, again, on fraction type problems like these, is when you have operations in the numerator and denominator, simply ignore one and start with the other. I personally usually start with the numerator. So that would be 3 plus negative 8. Now, in that numerator, there's no other parentheses. There's parentheses, but it's simplified already. It's just a single number. All right, and this is the final problem for this classwork here. We got negative 1 minus 7. And that's multiplied by the square root of 64. Now, we know square roots are part of the parentheses order of operations right there. So we're going to take the square root of 64 first. And the square root of 64 is 8. So now my new problem shows as negative 1 minus 7. And again, it was multiplied by that square root of 64. So it is now 7 times 8. And that takes care of all the parentheses we had. I don't see any exponents here. So I'm going to check that off, and I'm going to go straight to the multiplication. 7 times 8 is 56. So now I've got negative 1 minus 56. And there's no division, no more multiplication, so we'll check that one off as well. I'm already on subtraction. Now for this one, I'm going to make it adding a negative 56. And the reason I'm doing that is because I know by combining negatives with addition, a negative and a negative is going to be still a negative with addition. But it's going to be a bigger negative, so you do 1 plus 56, which is 57. And again, it's not necessary that you use that method, but it is valid. And it's the method that we're most used to, so that's the method I'm using. And that takes care of addition or subtraction. So that's our final answer on this one. All right, and that concludes this classwork. Hopefully it was helpful for you guys. You have the examples on the left. You can compare those to the ones we were doing. But again, it's always the order of operations. And again, the first purpose of the order of operations really is to make so that the process of doing the problems is the same. So we don't get different answers for the same problem. But the second purpose of it is to break down math problems into smaller, more manageable problems, which hopefully you've seen as we've gone over this section of Unit 7. So thanks for watching, you guys. Let me know if you have any questions, and we'll talk to you in the next section.